Hey everyone, welcome back to 51% Crypto Research Podcast. I'm your host, Tom Shaughnessy. Today, I had the opportunity to speak with the founders of Near Protocol, Alexander and Illia. Ironically, I was on the phone with them discussing the platform because I found their Medium post very interesting, and I said, hey, let's jump on the podcast to record, and we got started. Despite being very fresh to the project, we had an awesome discussion. We discussed Ethereum's plans for Serenity, which includes Sharding and Casper all rolled in, why the Near team believes this release is not a 2020 event, but likely 5 years or more away, and why the Near protocol can win first. Look, we're all aware of the wide array of Ethereum competitors that have come and gone, and the ones that still exist today, like Tezos, EOS, etc. Although having these conversations are invaluable, since you learn the criticisms of the major platforms from outside teams, you could potentially find the next big idea, and you keep an open mind on other ways to build these projects. One thing that caught my attention is the Near protocol is very similar to Ethereum's Serenity. And the team believes that having an experienced and centralized team can deliver sharding and the benefits years before Ethereum rolls out with Serenity. As an aside, for those looking for legitimate and extensive crypto research, visit 51pct.io to access our latest research full of actionable and original analysis. In a world of 1,000 alerts, we email our subscribers rarely, on average 1 to 2 times per month, since we focus on delivering original and extensive analysis beyond alerts. With that, here's my conversation with Alexander and Illia. Hey everyone, welcome back to the podcast. Today I have on Alexander and Illia from Near Protocol. How's it going, guys?
Hi, going very well. How are you?
Great. Good, thanks. It's a pleasure to have you guys on. I saw your Medium post recently on why Near isn't just replicating Ethereum's Serenity design, because you guys are building what appears to be a similar system, but there's a lot of differences. So I wanted to go through that. But first, let's start with how you guys got into crypto and a little bit about your backgrounds.
Sure, yeah. So Alex and I have been working on a different startup for a year before we got into crypto. We kind of coming from 2 different backgrounds. I mostly worked on machine learning, going from a smaller company to research. Alex worked for 5 years at MemSQL, a distributed database company. And we got together excited about program synthesis, which is a technique to generate code using machine learning. We were very ambitious and wanted to automate a big chunk of programming and started a company pretty much April last year. And somewhere June this year, we realized that this idea was too ambitious, and kind of as we were exploring where to go from there, we stumbled upon blockchain. We have a couple friends who joined us now to work on our project, and we were talking with them, realized that there's a huge gap between both scalability and usability in the blockchain that we can fill in with our expertise, and that's where we are.
That's interesting. So, I mean, before we get into the Near Protocol platform, I just wanted to zoom out and, there's been, thousands or hundreds or thousands of, Ethereum killers that have come out that basically, have failed that people don't really remember. And then there's the platforms today, which are struggling to keep up with the community and the plans. So I have to ask, why would you decide to build your own platform versus just building on Ethereum?
Right. So when we were exploring what exists today and what is being built today, right, and there's hundreds of protocols being built probably, there were a few things. So one thing is that all of them try to solve scalability. So I don't think there's any protocol that claims they will have 14 transactions per second, though very few of them actually build sharding. So majority of protocols solve scalability by pushing more transactions on a single machine, right? So many of them would have a single machine that would be a leader, which will be processing all the transactions and some process to re-elect it, or they will have consensus among few nodes, which are resampled every now and then. And because there's fewer nodes that need to reach a consensus, the protocol can work faster. And then if you also replace, let's say, VM with WASM, you can process more transactions per second, and then it gets pushed to hundreds, thousands, or tens of thousands transactions per second. In reality, for a protocol to be future-proof, it needs to be sharded, meaning that as the number of participants grows, number of transactions processed also grows. And there are very few protocols that build sharding, right? So Ethereum is one of them, right? Ethereum is building sharding, but their roadmap is, it's multiple, it's many years from now, at least 3 or 4, maybe 5. There's a couple others like Polkadot that build something meaningful in this regard, but there are very few. Maybe there's a dozen of protocols that build sharding. And then, go ahead.
That's interesting. So I guess at the forefront, you guys are leading with Near Protocol differs from Ethereum Serenity in that you guys have sharding to begin with, and Serenity plans to have sharding in hopefully 2020, but you guys believe it will take even longer?
So we follow very closely their progress. We talk a lot with the teams that actually implement sharding, and we follow the research. And 2020 is a little aggressive with their approach, right? And also, even when they close to shipping, even just transitioning from present Ethereum to Serenity will be a relatively slow process and probably very painful.
What's the main concerns you see in the delay? Like, why would they not hit the 2020 mark?
The primary problem is the way they approach it is that they don't have, like if you compare it to us, right? We have 9 people, super strong. If you like go to our website and look at the team, look at our backgrounds, we have a team with backgrounds from. Majority of us built distributed systems before. Some of us have, like more than 7 years of experience in distributed systems. We all sit in the same room in San Francisco. All of us are full time, right? So it's a very dedicated effort of a very strong team. Majority of implementers of Ethereum are not like that, right? So those are teams of people who, first of all, are significantly more junior. Second of all, it's mostly distributed teams, which also slows down the progress. And many of them are not full time. So some of the teams are not full time. Some other teams have full time engineers, but their company's primary focus is not building the protocol, right? So for some companies, it would be building some enterprise solutions. So they have no incentive. Or like even overall, there is no large incentive to ship Ethereum Serenity, right? There is no, so they have grants from Ethereum Foundation, but there's no aligned incentives. And so I think that all in all slows down the progress quite a bit. And also there's a disconnect between the research, which happens in Ethereum Foundation, and the implementers, which are a series of separate companies, right? So there's this communication barrier.
That's interesting. So I think you bring up 2 points that we have to discuss. I mean, the first one is, I know that you guys have a dedicated team, but don't you think that people will knock you guys for, in essence, being centralized? Or is that something you don't think about from the development perspective?
We believe development in general is like being centralized for development is not a bad thing if you are transparent and your code is open source. You encouraging open source contributions from people of outside. Like generally, especially in the beginning, I mean, Ethereum was like a team of people working on it, even if they were not like sitting in the same room all the time. They were collaborating very closely from the start, right? So like, it's really hard to build something like, especially new, if you don't like share kind of DNA from the beginning. Like if you're working in this kind of more loose way, which is what right now, in general, like this decentralized kind of promotes, right?
Got it. That makes sense. And then I guess, it is a trade-off. I mean, Ethereum does have a global community of thousands of developers working on different projects, but I guess what you guys are saying is that if you could centralize building the base layer, you can build faster?
Exactly, yes. Yeah, we would love external contributions and like help of community to build all of the like additional layers and wallets and SDKs, and we have like a pretty good roadmap for all those things. We would love to get people on board across the community, but like the core like layer 1, networking consensus like protocol, that is all like it's actually not that much code at the end, but it's something that requires a lot of like attention to detail and like conversations to figure out the exact right way to do it.
Got it. Well, to be honest with you guys, it's definitely a different strategy. We're going to have to see how it pans out. But just moving on a bit, I want to get into, the specific differences between the Near protocol and Ethereum Serenity design. So I know we talked a bit about sharding. Let's start there, if that makes the most sense. The main benefit of sharding is higher transactions per second, higher throughput. With Ethereum, they're aiming for 1,024 shards, transactions per second in the realm of 10,000 to 15,000 per second. What are you guys aiming for with sharding on the number of shards or transactions per second?
So in terms of number of shards, when we're going to be launching, it's not going to be large. It's going to be probably, as a matter of fact, we're going to get to that later probably, but we most likely, when we launch, we will not have sharding at all. And then we will go through a series of on-chain updates to get to the sharded blockchain. But once it becomes sharded, it's probably going to be on the order of several shards. So let's say 10 shards maybe. And then it's going to be increasing over time with the growth of the network. Because if you don't have, the biggest problem with sharding is that, and that problem will actually exist for all the sharded protocols that are launching, is that for sharding to be secure, every shard needs to have some minimum number of nodes processing it. Those nodes need to rotate, but in every given moment of time, the number of nodes in every shard need to be sufficient to provide some security. And like, for example, in Ethereum today, the total number of nodes is 15,000. It's a pretty large number, but if you want to have at least, let's say, 150 even or 200 nodes in every shard, that's
100,000 nodes for 1,000 shards.
Yeah.
Like the Ethereum design currently is 1,000 shards, so they need 100 to 200,000 nodes actually participating in the system.
But today they would have like 15 shards, right?
Yeah.
Yeah. Today they will have like between 10 and 15 shards if only the existing nodes will continue participating, right? So and so every sharding protocol that launches, they will have this problem. How do we get more nodes participating? And the primary way to do that is you reduce the barrier to participate. Today, participating in a network is very hard. Right? There is proof of work, where effectively you need very expensive hardware to be competitive, and every node needs to store the entire state. Right? The state in Ethereum today is 100 gigabytes, or maybe even bigger now. So you need a node which can store that amount of state, that can then load that amount of state and process it. So some things that sharding give you, sharding and proof of stake combined, is that first of all you don't need to compute hashes anymore, but second of all, every node only stores a subset of state. You can get more nodes over time, and that will scale over time. But at the beginning, the number of nodes is small, so the beginning number of shards has to be smaller.
I got it. So just zooming out, so Ethereum, I think originally wanted 15 stakers to put up 1,500 ETH to be a validator. Mm-hmm. It's since come down to 32 ETH. So that the barriers are lower, so you could have more validators. You guys are saying that the barriers are still too high and they won't be able to attract enough validators, and then that won't be able to service the amount of shards that's required to run the network. Is that the gist?
Oh, not quite. So I think Ethereum will be able to attract more validators. I'm just saying that with the present number of validators, that would not be many shards. So they cannot just launch with 1,000 shards because they will not have a sufficient number of validators immediately. There will be some transitioning period as validators actually, join. So that's what I meant previously when I said that the process of switching to Serenity will be somewhat painful. But by the time they fully switched, probably with a 32 ETH barrier, they will have sufficient number of validators to run quite a few shards, especially given that they already have the community figured out.
Understood. So just going back to you guys, what is your competitive advantage on sharding though? Is it the throughput, or is it lower barriers to entry, or what exactly is it?
So if you compare our design with what Ethereum will have eventually, they're very similar, right? So the advantage in terms of design of the sharding itself, I wouldn't say we have a huge competitive advantage. There are minor differences that I described in the blog post that you mentioned earlier, right? So there are certain trade-offs you can make when you make decisions in terms of which consensus to use, which fork choice rule to use. So that is in the blog post. We can also cover it here. The primary difference is that we're going to launch significantly faster, right? So our sharding will be available earlier, and then after that, we primarily plan to differentiate on a completely different level, which we didn't touch upon yet. which is usability, right? So Ethereum, once scalability is solved, the second biggest problem with blockchain adoption is the fact that the barrier to start using Ethereum for a user is very high, right?
Got it. So I guess your main argument is that the protocols are pretty similar, Near Protocol and Serenity, but you guys are planning to launch sooner because you have a more centralized development team, which, I mean, in theory, it makes a lot of sense, but just playing devil's advocate for you guys, it's very hard to compare a network that isn't launched to one that is. And, now to play the other devil's advocate for Ethereum is that they also have to rebuild their entire protocol when they launch Serenity, basically. So, how are you guys so confident that you could launch years before Ethereum? Because to me, it sounds like you guys are still 2 years out, and Ethereum advocates will argue that they're also 2 years out. So, why will you guys launch so much sooner?
So one thing is that we already built a prototype of the network in Python. That was the first thing we did, right? So unlike many other protocols that immediately publish a white paper and then start building the protocol itself, we first built a prototype. It is very important in engineering in general because many assumptions that you can put on paper will not validate once you start building them, right? So at this point, we know exactly what is possible, what is not, and how far we can get. And now the only question is, how much time will it take us to build the production-ready version of the same code in a lower level language? In our case, it's Rust, and that should not take, like transpiling code from one language to another should not take many years.
Got it. That's cool. So I guess let's just go over, the basics of the platform itself. I mean, what are you guys aiming for on, let's just rattle through the key aspects of the platform. I mean, how many nodes are you aiming for? What's the consensus type? Let's just go through all the basics for the listeners because, this is a slightly more technical podcast episode where we're comparing Serenity to Near. So we might as well just go through the aspects of the overall platform.
Right. So in terms of number of nodes, that's the beauty of sharding, that it scales linearly with number of nodes. So at the beginning, we will need to have some minimum number, like for security. But the idea right now is that there's a certain number of validators per shard, which we're building with a constant. We plan to have 200 validators per shard. We still do some security analysis to see that is sufficiently secure, right? So that is a constant that can be changed last moment. But also those nodes, effectively, if you have sufficient stake and a sufficiently heavy machine, you can be processing multiple shards. Then in terms of consensus and in terms of how sharding works in general, the design is similar to Ethereum. There's a beacon chain, or like different protocols call it differently. It's called relay chain in Polkadot. Yeah. So that's the main chain which effectively orchestrates the system. So that chain decides who will be validating which shard at which point. It also serves as the means of finality on the shards, or I guess means of the higher security finality. And each shard is a separate blockchain which has its own consensus, its own validators. The validators are frequently rotating, and the shards are what actually stores the state and do all the processing. And shards have their own so effectively what happens is if you send a transaction, it gets accepted by the shard. Shard publish blocks every few seconds. And so the moment it is in the block, on each block, validators within the shard reach a Byzantine consensus. So if you believe that the shard is not corrupted, if you believe that the shard, the validators in the shard have less than 1/3 of adversaries, then you can be certain the transaction is irreversible.
That's interesting. So I guess a lot of the aspects of the platforms are pretty similar.
Yes, that's correct.
Interesting. So I guess just moving on to the fun stuff for the retail investors and everyone else. I mean, what's the launch going to look like?
Pretty much the idea is to not do ICO. But what we're planning to do is to have a proof of care sale where people can buy our token, but the proceeds will go to charity. Partially, it's motivated by giving back to community, partially by the fact that ICOs in US and like in many countries now are getting more regulated and getting into like grayer zone. But what we are really more interested is on what we call a conditional airdrop. And the idea here is we want to get as many validators as possible when we launch. And to do that, we will reward people who will start by validating. We have kind of on our plan, because it's a sharded network, the node that can validate each shard can be small enough that it should fit on a mobile phone. Because the idea would be that people can install our app ahead of time, ahead of the launch, and they will have a conditioned token airdrop to them. And if they pretty much validate, if they use their phone to validate for next 30 days, this token will become theirs. It's kind of like you get your stake so you can validate, and you kind of retrieve it back as airdrop after given on a condition of you actually participating in the network.
Got it. I mean, do you think that might be hard to do? The name is, I think it was Civil's token sale. I think that they required people to use the tokens in some aspect. I'm not too versed on that subject, but I mean, that's a high barrier to entry, to require people to use the token when doing a sale. And to be honest, I haven't really seen it done well. I mean, do you guys envision that could be a problem?
So we're planning, our goal is to make it as easy as you download an app from an app store, and then pretty much click a button saying, I agree, maybe activate with your phone number. And then your phone will work in background or in foreground at night. And then in 30 days, it will kind of, you'll get the token unlock. Idea here is, we want to work with designer and product people to actually make this experience as easy as possible.
Got it. That's interesting. So you just said that the Near protocol is going to be mobile friendly. What exactly does that mean? Is that like a light node, or what is that about?
So the idea of sharding is that because each shard kind of processes way smaller amount of network, right? Not all of the transactions, not all of the state needs to be stored. We're planning to have a validating node that can fit on a high-end mobile devices.
So if you have Galaxy Node, or if you have iPhone X, you would be able to run a node, which is not just a light node. It's a full node which operates the one of the shards of the network.
Got it. I mean, isn't there a lot of problems with mobile nodes? I mean, I know Peter, I can't pronounce his last name, but he's the developer at Geth. He voiced some concerns over light nodes having security flaws or just sharing too much data. I mean, what has your research shown you there on light nodes?
So I mean, in this case, this is not really a light node because it does track the chain. There is some bandwidth kind of limitations, and part of it we working on the network layer to help. But the other part, it's probably that you can validate only when you're on Wi-Fi, for example.
Got it. It's because you have a faster connection speed?
Yeah, faster and more bandwidth.
That's interesting. So that's cool. So I wanted to just go back to the proof of stake or not. I mean, you guys aren't using proof of stake, right? Is your consensus mechanism?
So we're using proof of stake. We have this kind of flavor of it called thresholded proof of stake, which instead of saying 32 ETH is your threshold, we say, let's find the smallest threshold possible to fill in to get as many people as possible to validate.
Also, so proof of stake is not a consensus mechanism. Proof of stake is the Sybil resistance mechanism, right? So when people say proof of work, proof of stake, this is how you make sure that people do not, print 1 million accounts and participate with them. In terms of consensus, we use a thing called TXLow, which it's a in-house built Byzantine consensus on both. It is DAG based, and we use it on both beacon chains and shard chains.
Got it. But how do you compare for validators? I mean, on Ethereum, at a 32 ETH to become a validator, it's, I don't know, something like $6,000 or $6,500 to be a validator. And then the inflation rate is going to be, I don't know, 0.5%, something in that range. How do you guys, I mean, if you haven't thought about it yet, it's fine because I know it's not launched, but have you thought about, what what the likely requirement's going to be a validator, or what the inflation could be? Because I think investors are going to start thinking about these things, or users, because if the requirement to be a validator is lower and the inflation's lower, it kind of makes for a better network. For investors, on the flip side of that, have some security concerns. But how do you guys think about those two things?
So in terms of how much you would have to stake, I was writing a blog post which I might publish within a week, maybe or two, with some math, with the idea that if the inflation, so let's say the inflation is fixed for the system, let's say it's 5% per year, so the entire system would inflate by 5%. In that case, if you stake, let's say every single person stakes money, right? Every single person on the system stakes and participates. That would be a disaster because then there's no tokens to exchange. But in that case, every single person would get 5% yield. Now, if only 10% of people stake and validate the system, then every single person now suddenly gets 50% annual yield because the system inflated by 5%, and that was split among 10% of people who participate. Right, and so if 5% stake, then everybody doubles money every year. So that creates some sort of a supply-demand curve, where if the yield is above what most people would consider sufficient to participate, more people will join and the yield will drop. And if it's below what most of the people would find reasonable, then some people will drop and number of validators will reduce, and it will increase. Because there are so few proof-of-stake systems, it's very hard to tell where exactly that will converge. But if it does converge, let's say at 5% or 10% of validators, then as Ilya mentioned, thresholded proof of stake has an adaptive threshold. That adaptive threshold would end up at approximately the same value as Ethereum. So if our system had the same valuation as Ethereum, and then 5% of people were staking, then the threshold would be approximately 32. It would be as much as 32 ETH in our tokens.
Got it. So I just interviewed Emin Gunsur of Ava, who's creating or building on top of the Avalanche platform. It was a great interview, and one of the things he talked about was he wasn't a huge fan of setting arbitrary numbers, like in Bitcoin you have the 21 million token cap, et cetera. You guys are kind of taking the same view in that you want the inflation rate of the number of validators and the requirement to become a validator to be dynamic based on the market.
Right. So one thing is that so we work a lot with a few very prominent economists in the field, from University of Chicago and a couple other places, to figure out how exactly that should all work. And I think so far there's very little research in general in this area that happened, and it's very hard to predict how any decisions that we make up front that's supposed to have very long-term effect will work out. For example, we don't know yet what will happen to Bitcoin once reward goes to zero, right? However, what is important is that, let's say that by the time reward for Bitcoin goes to zero, the system starts collapsing. Let's say validators drop out, miners drop out, and the system loses security. It will not fold. Instead, what will happen is they will hard fork. They will hard fork and they will keep the positive reward. So the idea here would be to put some meaningful constants, the best we can figure out today, and then on top of that have some meaningful way of how the system can evolve. So have some sort of governance, something that like Polkadot or Tezos, they invest heavily, or Cardano, they invest heavily in governance. We're also looking into that, and we will have some sort of on-chain governance that would enable the community to adapt, to change the system if they see that the constants that we set up front do not work.
Got it. So in line with kind of your dynamic take here to proof of stake in a way is the ability to change the platform. And this segues perfectly into governance and how those changes are actually made. Ethereum basically does it by the community and the core devs and the miners. Tezos or Tezos, however you want to pronounce it, they have on-chain governance, which is one token, one vote type idea. How are you guys thinking about governance, and what do you expect to implement?
So there's two things kind of here. One is, as Alex mentioned, there's not many networks actually launched, right? I mean, Tezos just launched. We don't know what is this going to end up in. And governance, either on-chain and off-chain. There's no clear way how this should be done. So the way we look at it, it should be very iterative. So whatever we implement now should be something that people can, like people community and in people who are invested in this network should be able to change going forward. As that said, kind of our original idea is very similar to what, let's say, like Linux kernel and Python kind of have implemented for like an open source project. We call it benevolent dictator for now. Idea here is that kind of having a decentralized team deciding going forward after the launch is not efficient for actually implementing changes versus having one entity that is responsible but has checks and balances on them may be beneficial for evolution of the network. So the idea here would be that, let's say, in our case, Near company would continue evolving the network for next year or so, and there will be checks and balances. There will be kind of elected set of individuals who are either researchers, in crypto, in economics, etc., developers on the platform, and other kind of influential people in the network. They are kind of a board that makes sure that what this benevolent dictator entity does is actually legit. And if they see that this entity becomes not like doesn't satisfy the requirements, which also should be kind of stated ahead of time, they can remove this entity from being able to evolve the network and find another entity that would be responsible. And of course, there is a general vote that would allow to switch this model into something different as we figure out better how to do governance for blockchains.
Got it. So I guess just a few points there. I mean, I think that people are value governance way more at the protocol level. So like Ethereum, Tezos, Bitcoin, you guys. And then as you work your way up the stack a little bit, it becomes somewhat less of a concern. I think that those projects have more leeway. I'll give you an example. So governance in Ethereum is a huge debate, right? But governance in the 0x protocol is not as much of a debate, even though 0x's tokens currently don't have any governance functions at all. But the plan is to embed governance functions in them over time, which I do like because they don't have to make a decision today and they could figure out what works best. But I mean, you guys definitely have a hard road ahead of you in figuring that out, because the change from no governance to governance is definitely going to be a tough one.
Like we're starting with a somewhat centralized governance model. And the idea here is that, at least from the past, a president of a country or CEO of the company so far is able to pool resources and organize efforts a lot more efficiently than a kind of less invested maybe team of decentralized entities or people trying to coordinate between each other. That said, like we in any way saying this is the best model, we just suggested as experiment, and also we believe this is a good way to evolve the network for a first year anyway. And we allow like a community that will be built around the network to switch this model if they see if there will be research on a better model, kind of evolve it into that.
Got it. Okay. So, just to zoom out, I like thinking in extremes with these things. So let's say that you guys are, wildly successful. You have your mainnet launch in March of 2019, which is on your website, and then your dApp store launches. How are you guys, I guess two questions here for you guys to sum up. I mean, one, how are you guys going to attract developers to your platform? Because Ethereum's community is gigantic. And the other thing is, how are you guys going to compete with other chains that, already promise high throughput already, but are also probably too centralized, like EOS or Neo or Zaliqa or something like that? So
here, we actually believe that usability, both for developers and for users, is kind of our main attractive point. So let me start with developers. Kind of our belief is that, there's a good community around like Ethereum developers and kind of blockchain developers, but it's still very small compared to 13 million developers kind of around, let's just call it Web 2. The Ethereum community is very small. So what we want is to build enough tooling and enough kind of educational materials so that a regular developer, web or mobile, for example, can go and build their first contract connected to their application within 15 minutes. That's kind of the level of developer usability we're aiming for. And for that, we making sure that like our smart contract language will be TypeScript, which a lot of people are familiar with. We're making sure that our mobile and web SDKs are easy to use. We can automatically generate from your smart contract an SDK you can plug in your app, make the deployment and kind of development easy through IDE and stuff like this. So like a lot of tooling on this side. And then on the user side, like right now, as a user of Ethereum, it's quite complicated to do anything, right? You need to like from setup time to actually using application to moving between things. It's all like kind of quirky, requires, like public keys, etc. So here, a lot of people already in the Ethereum community have thought of improvements, right? From like universal login, contract-based accounts, all kinds of things like that. So we're exploring a lot. How can we bring all these ideas, if not on a protocol like L1 level, but like pretty much be native to these concepts when we launch. And here, like one thing we really interested in is how to remove fees from transactions, because right now this is kind of one of the blocking points in general for users, is that when you're trying to use the app, you actually need to pay before you get any value, right? That is not how pretty much users are known to operate. So figuring out how to remove those fees, which also for the sharded protocol is like in general a problem to how do accounting across shards. So this has like a lot of value to figure out how exactly we remove this problem.
Got it. So, I mean, I just building on that. I mean, we already have Near protocol is not going to be competing with Ethereum today, Tezos today, or EOS today. It's going to be competing with those protocols, a year from today, because that's when Near's going to launch, and that's where those protocols will be at that time. So, I guess one of my last questions for you is, kind of like a velocity question: is how do you guys know that you can not only build but build faster than these other platforms and accelerate your growth beyond theirs?
So I guess one of the biggest reasons why we should be able to build faster is because our team is straight up stronger than for most of them, right? There are very few teams coming from the industry. For some reason, in general, blockchain was attracting a lot of teams from academia and very few teams from industry, right? And building distributed systems, you need industry experience. Besides that, we also, so another concept I wanted to cover at the end is we also plan to iterate, to have very iterative approach, right? So we have this concept of MVB, which is, we call it minimum viable blockchain, that we will launch, we will see, maybe even before March, which effectively will cover practically everything except for sharding. And then from there, we will be iterating. And so that iterative approach is something that will enable us to differentiate from many other protocols which want to build a full system before they launch, right? And so that will delay them quite a bit. But besides that, if we just even compare to the existing blockchains today, so like let's say Tezos, Polkadot will launch soonish, I hope. The market is pretty large, right? So at that point, we will not be competing against each other. Rather, potential market is very large. So rather than competing against each other, I think our primary competition will be how do we bring more people to the blockchain space? How do we make the space more attractive? And
got it. That's interesting. That's some good color. And yeah, I just want to zoom back out, Alexander. For those who haven't read your Medium post, it's great. Are there any? I just wanted to walk through the benefits or the arguments of using Near over Serenity, just to close out. I know that we've discussed that you guys believe you can build faster. You think you'll have your protocol out first. You think you'll have sharding first, and you guys are mobile friendly. Are there any other differences that you wanted to discuss, based on your Medium post or anywhere else, on why you think you guys are in a stronger position than Serenity?
I think I will actually emphasize again the argument that Ilya was just making, that ultimately for users, that's not going to be the scalability, that's going to be the decisive factor. And moreover, so many protocols, including ourselves, we're competing for very large transactions throughput and very low latencies. Ultimately today, even if someone comes in and provides 100 transactions per second with a protocol which is credible and that people trust, that would be already more than sufficient to cover all the use cases existing today, right? So like CryptoKitties and IDEX, like maybe two out of 5 biggest contracts today, they don't have that many users and they don't have that many transactions per second, right? We're not blocked yet on not having, hundreds of thousands of transactions per second. So I think for users, ultimately it will be the usability. If users can just start using your app without setting up, public and private key and figuring out how to store them securely, if they don't need first to buy some ETH to pay for gas before they can, execute the first action on the app, that will significantly lower the barrier to start using applications. And once that barrier is removed, that is a large motivation for developers to develop for the platform, because they can actually later easily attract users from outside of the ecosystem, right? From significantly wider set of people. So I think that's going to be the usability. That's going to be the primary differentiating factor. And
Alexander, just to hit on that a bit, I mean, that's interesting. And I totally agree. You lower the UX hurdles and the UI hurdles and you get adoption. I totally agree with that. But my only counterpoint is, I mean, isn't that a discussion for, one step up the stack? I mean, isn't that a discussion of not Ethereum itself, but the decentralized applications building on Ethereum? Aren't you then competing with all of those guys on usability? Because it seems to me that the decentralized apps building on Ethereum, it's their goal to lower the UX UI barriers, and Ethereum itself on the protocol layer isn't too concerned with it. Or, how do you think about that?
So when I play, like, let's say I'm playing some blockchain games, as a matter of fact, the games themselves today have very, very nice experience. The primary pain points that I have today when I play a game on Ethereum or on EOS is what is imposed on the developer by the platform, right? So I cannot play any game on Ethereum until I actually have MetaMask installed and my private public key pair set up, right? So that part is painful. The moment that is all figured, like let's say I already launched it in MetaMask, let's say I have MetaMask configured, many of those applications have very nice user experience today, right? So that is, developers are already doing pretty good job, but the protocol does not allow them to have seamless experience for the users.
There's actually like 3 or 4 ERPs that happened that were trying to improve the protocol for this kind of use cases and never actually went through, because changing Ethereum is quite hard. So there's like developers and people from Ethereum Foundation themselves that realize that there's improvements they could have done to the protocol level to dramatically improve the experience. But changing kind of already moving train is quite hard.
Got it. And that's interesting. So I guess, I always come back to this when I look at a new platform. When I'm comparing a new platform to an existing platform that has to change, I think people really have to think about that changing an existing platform from the ground up, starting over, is a lot harder than people think. And I know there's a ton of very experienced Ethereum developers working on this, but do you guys have any examples on any platforms that had to undergo such a change, just to put into perspective how hard this might be?
So yes, I can sort of tell you from my experience back in. So I'm coming from a company called MemSQL, and MemSQL is a database platform, right? So it is centralized, so they don't need to reach a large consensus among the community. But from day one, what MemSQL was doing was that if you run a query, the query would transpile into C++ code, and C++ code would get compiled, and that would be slow. That would take 5 seconds the first time you execute a query. Every consecutive invocation would be super fast. But the experience was very bad. This is actually so many parallels here, right? Experience was terrible. The problem was that C++ generation was spread out throughout the entire code base, right? Because that's how MemSQL was built, and it wasn't very well abstracted out. And so at some point, it was clear that it cannot evolve any further without that being changed. And there was a huge effort. MemSQL had to hire a super senior guy, maybe the only person on earth who could have solved this, who built similar like transpilers before. they had to assemble a team of like quite a few people, and that was like half a year effort, if not longer, to completely refactor the entire system. It was super painful. Ultimately, it succeeded. But if it was built from day one with the proper code generation, obviously that pain would have been avoided.
Alexander, that's a good example. Is that now, if we relate that to Ethereum rebuilding their network, in your mind, because we have to talk about this, because critical to your success is the delay, the potential delay in Ethereum with Serenity for you guys to move fast here. So if we think about that idea, in your example, you had one guy that fixed your platform. In Ethereum, there's thousands that all have to work together. Does that hurt or help that there's so many Ethereum developers? Because they all have to coordinate on one side, which is slow and time consuming, but on the other side, they have 1,000 or thousands of great minds working on this. So what do you think there?
Actually, now that I think more, I think my example wasn't very good, because in Ethereum, the biggest problem is not refactoring a lot of code. In practice today, to build Ethereum client from scratch for Ethereum 1, that is actually like you can build Ethereum 1 client from scratch today in maybe like a couple months of concentrated effort. So in Ethereum, the significantly bigger problem is there's no process to change the client effectively for small updates, right? So they have some process that how to undergo major updates that are scheduled. But if they want, for example, let's say tomorrow they realize that they can have meta transactions built significantly easier if there's a minor change on the protocol level, right? If it was Tezos or Polkadot, that would be, they will make a change. They will do comprehensive testing. They will make an on-chain. They will propose an on-chain update. If that's a huge benefit for the community, I'm pretty sure they will just vote that change in, and the on-chain update will happen. In Ethereum, that's completely infeasible today because of how many people are involved. Or like the extreme case would be Bitcoin. On Bitcoin, you cannot change anything. Ethereum is slightly less extreme. If a change is super beneficial, such as sharding, they will naturally upgrade to it. But like small changes are completely infeasible, right? And so that brings back to good on-chain governance. If you have good on-chain, or not even necessarily on-chain, if you have a good governance process, those updates will be happening.
Got it. So Alexander, in your mind, and I know this is hard to mentally switch for everybody listening, but transactions per second, decentralization, these are all key topics to discuss. But what you're saying is that paramount to the platform should be the ability to evolve over time with, speed and agility. And something like Tezos can do that because it has on-chain governance, and something like Near Protocol is able to do that. Whereas in Ethereum, that's very hard to do because it requires so much coordination.
Yes, that's correct. Also, Vitalik famously said that he's opposing on-chain governance. You can, I think it's somewhere on Twitter. You can find his opinion.
Why do you think he's so opposed to it? If it's so great, I mean, look, don't get me wrong. It could definitely allow a platform to evolve faster, but it seems like it also introduces issues where you could have major changes get voted on. And then you also have the problem of, are people really going to sit by their computer and vote on changes all day, or are they going to delegate their votes? You have all those issues. So, why do you think Vitalik is so against on-chain governance?
So I don't know. I don't remember why Vitalik was against. He motivated it. I don't remember his point. But so the answers to your questions. So there's liquid. It's called liquid democracy, right? And there's liquid
liquid proof of stake and delegated proof of stake. They're very similar.
There's also this thing in Definity called Neuros system, which is somewhat similar, but more. There are more details available. It's very well spec'd out. So there are ways to sort of change the voting, but still governance is at the very early stages, and you can never. It's very hard to predict how many bad things can happen, right? Is it possible that very very few Twitter influencers can make people to vote for something super stupid, right? So all of that is a very important considerations, and that is one of the reasons why we want to ship MVP early and start iterating and see how governance actually works in practice, to see if that is something meaningful or if it's something that needs to be changed.
That's interesting. Well, Alexander, the Near Protocol is interesting. You bring up a lot of points that, whether or not you like the Near Protocol or whether you are an Ethereum Serenity bull, you bring up a lot of great points that people have to think about for both platforms. So Before I let you go, is there anything that we didn't discuss that you'd like to take this opportunity to talk about?
No, I think we covered everything.
Awesome. Well, Alexander and Ilya, it's been a pleasure having you on, and I'll definitely have you back on again to discuss some updates.
Awesome. Thanks.
Thanks for listening to the podcast. If you enjoyed this episode, please rate and review it to help other people find it, and head over to 51pct.io and sign up for our extensive research alerts so that you can have an edge on your competitors.